Hello students, and welcome to our lesson on integer multiplication and division. We're just going to be covering the basics here of how positive and negative numbers interact with each other when we are multiplying or dividing, and then use a couple application problems at the end to make sure we understand what's going on. So first thing is multiplication of integers. Multiplication, we should already know, is shorthand for repeated addition, but it is only shorthand for repeated addition if both numbers are positive. So for example, if we have 3 times 4, that means that we're going to do 3 jumps of 4 each. So we can see 1, 2, 3 jumps, and each of those jumps is 4 units big. So we go from 0 to 4, 4 to 8, and then 8 to 12, which is why 3 times 4 gives us 12. Okay, 3 jumps of 4. Now, writing it as multiplication not only saves us time, but it also gives us other ways to calculate. And by that, what I mean is when we have big numbers being multiplied together, it not only saves us time in writing it, but in actually calculating it. So as a quick reminder over here on the side, we're going to work out a problem. We're going to do 102, and we're going to multiply it by 11. Now let's go 13. Okay, so we're going to do 102 times 13. Now, can you imagine having to write out 102 jumps that are 13 each? That would take so long, and nobody wants to do that, okay? So instead, we can write 102 times 13 to represent jumping 13 units 102 times, but then we can actually calculate it by knowing how to multiply multi-digit numbers. So real quick, I'm going to remind you how to multiply when you have multiple digits. So what you do is you focused on the first digit of the bottom number. So in this case, we're going to be focusing on this 3 right here. And so we're just going to ignore the 1 for a second. We're going to multiply 102 by 3 and put the result down below. So we go one digit at a time. 3 times 2 is 6. 3 times 0 is 0. 3 times 1 is 3. And that's it. That is 102 times 3 is 306. But then we jump to the next digit in the bottom. So now looking at this number down below, this 13, I'm going to ignore the 3 and focus just on the 1 and multiply 1 times 102. But what I'm really doing is not multiplying 1 times 102. I'm multiplying 10 times 102. So you have to imagine there's a 0 where the 3 is. We're multiplying by 10 now. So what I have to do to account for that is put an extra 0 right here to start, and then start multiplying 1 times the digits on top. So 1 times 2 is 2, 1 times 0 is 0, 1 times 1 is 1. And then what we do after we've done this for every digit that's in the bottom number, then we add together the results. So we're just adding vertically. 6 plus 0 is 6, 0 plus 2 is 2, 3 plus 0 is 3, and then a 1 just stays a 1. So we get that 102 times 13 is 1,326. Again, this is just to clarify to you that we have a reason for writing things as multiplication. I do not want to have to add together 13 plus 13 plus 13 plus 13 102 times. That'd be crazy. So instead, we learn how to multiply, saves us a lot of time. All right, now we're going to talk about negatives. So we can think of multiplication in a couple different ways. If we have a positive times a positive, like we did up here at the top, 3 times 4, we can think of this as repeated addition. So just like the one at the top, if we have 3 times 4, we're doing 4 plus 4 plus 4, where there's 3 of them. Okay. But what if the second number is negative? Okay. So if we have a positive times a negative, what we can think of this as instead is repeated subtraction. So imagine if we had 3 times negative 4, we would just go in the opposite direction each time. So instead of adding 4, we would be subtracting 4 each time. Right? And then if we have a negative times a negative, well, if we have a positive times a negative, that's repeated subtraction. But when we make the first number negative also, you need to think of that as doing the opposite of what it would normally be. So a negative times a negative is the opposite of repeated subtraction, and that's just repeated addition. So when we have both numbers negative, we can just think of it as the same as both numbers being positive, which is repeated addition. Technically, we're doing the opposite of repeated subtraction, but the opposite of subtracting is adding, so it just becomes repeated addition again. The moral of the story, though, that we actually need to take away from this is that if we have the same signs, a positive times a positive or a negative times a negative, our result will be positive. But if we have different signs, so either a positive times a negative or a negative times a positive, our result will be negative. And what we're really focusing on this lesson is just getting those negative signs correct. So example number 1, we have 6 times 3. Both numbers are positive. So we can just think of this as repeated addition. 6 times 3 gives us positive 18. Number 2, though, we have a negative 6 times 3. Now we need to think of this as subtracting over and over again. So we still do 6 times 3 like normal and get 18. But because of this negative sign on the 6, we're going to end up with negative 18. Okay, they have different signs, so we get a negative product. And then number 3 is if we have both numbers negative. So now we have a negative 6 and a negative 3. This is going to be thought of as the opposite of repeated subtraction, which is just repeated addition. So these two negatives multiply together to give us a positive, and so this is going to take us back to positive 18. So again, the only thing you really need to take away is what's down here. Same sign gives us a positive product. Different sign gives us a negative product. All right, now we're going to do the same thing for division. Division is the opposite of multiplication, so it means to split into groups is how we generally think about it. So for example, if we have 12 divided by 3, which we should know is 4, this means that if we had 12 objects, in this case, these 12 circles going across the screen, and we split them into 3 groups, so one group, a second group, and a third group, each group has 4 circles in it. So 12 split into 3 equal groups gives 4 in each group. Remember, we learned long division in our first essential skills lesson. And so even if we're dealing with big numbers, I'm not going to work out long division right now like I did this multiplication over here on the side, because we've already worked long division in this course. But what we want to take away here is just what to do with positives and negatives. And it's exactly the same as multiplying. So if we have the same signs, so if we're doing division and both numbers are either both positive or both negative, this is going to be a positive quotient. And if we have different signs, then we're going to end up with a negative quotient. So we can see the examples down below are all 30 divided by 6, but we just have negatives mixed in. If we have 30 divided by positive 6, this is going to be positive 5 because they're both positive. We can split 30 objects into 6 equal groups of 5. If we have 30 divided by negative 6, because one of these numbers is negative and one is positive, we're going to get a negative result. And 30 divided by 6 is still just 5, so negative 5 will be our result. Number 6, when we have a negative 30 divided by a negative 6, these negatives will now cancel each other out to give us a positive result again, and 30 divided by 6 is once again just 5. So again, all we're really focusing on here is making sure we understand when our product or our quotients should be positive or negative. Now let's put it into context with a couple applications. Just like in previous lessons, when we have gains, those are going to be positive values, and losses or debts will be negative values. Okay, so number 7, a person loses $25 every day for 6 days while on vacation. Represent this with multiplication and find the total loss. So what I have there is a little chart that shows us 6 instances of losing $25. And if we added together these 6 instances, okay, 4 25s would make 100, and then 2 more would make 150. So if we add these up, we're going to get negative 150. But we want to be able to represent this with multiplication. So instead what we can do, we are doing 6 instances of losing $25. So we can represent this as 6 multiplied by negative 25, where having parentheses around the negative 25 right here means to multiply by that 6 in front. So I don't have to put an X or a multiplication dot there. The parentheses already mean to multiply. So now we have 6 times negative 25 because one number is positive and the other is negative. We can go ahead and work this out. 25 times 6. 5 times 6 is 30. Carry the 3 up top. 2 times 6 is 12. Plus 3 is 15. So we get to that 150 that we already knew should have been the answer. But because we have a negative involved, we get negative 150. So I just take this number from over here, my multiplication, and I include that negative sign. So now we want to be clear that this has units on it. A person is losing $25 every day for 6 days while on vacation. So if we want to find the total loss, we need to clarify that this person lost $150. So we can either say negative 150 with a dollar sign on it, or $150 positive $150 loss. Okay, so either the left or the right both carry the same information here. All right, now let's do something with division. Integers, again, are going to be able to represent positive or negatives. In this case, we're going to be talking about above or below sea level. And division can model what is called rate of change. So for number 8, a submarine descends 300 feet in 10 minutes. Represent this with division and find the average rate of change per minute. So what we're having here is a submarine is going to start up here at sea level, which is 0, and it's going to go down and down and down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times until it gets down to negative 300. So what we want to figure out is how big are each of those jumps? Every 1 minute, how far is it going on average? So the way we can do this is with division. Okay, if we divide 300 feet divided by 10 minutes, okay, we're just working out division here, where in this case, we actually have negative 300 feet, okay, because this is descending. So we have negative 300 feet of change over 10 minutes. When we do this division, 300 divided by 10 is going to give us 30. And if you want, I can show you those steps on the side right here. 300 on the inside, 10 on the outside. 10 goes into 30 3 times. I subtract 30. That leaves me with a 0. And then 10 goes into 0 0 times. So I just end up with 30 with no remainder. So negative 300 feet divided by 10 minutes is going to give me negative, in this case, 30 feet. And now here's where we're going to talk about rates. We get negative 30 feet per 1 minute. Now we haven't talked about fractions yet, so this might be unclear. And that's okay, because we're going to build up knowledge of fractions very soon in this course. But right now, I'm writing negative 30 feet per 1 minute. But in reality, let's clean this up. What I actually just did was just division. Okay, all I worked out was negative 300 divided by 10. Okay, and this gave us negative 30. The units of feet and per minute come from the division. Okay, the word per, we're going to learn, means to divide. Okay, so whenever we see this word per right here, which you can see at the end of the problem, that always means to divide. And the way you write units is whatever unit was a part of the 300 in this case, so that's the feet, that is going to go on top of our unit fraction. And what's going to go on bottom is what we divided by. So 10 was minutes. So we end up, wrote 10 there instead of minutes. So we end up with negative 30 feet per minute, where right there, the division symbol means per. Okay, so if instead of writing it as feet over minutes, we could also write the same thing as being negative 30 feet per minute. Okay, so again, we're going to learn more about rates and fractions later in this course. This is just a real quick introduction to it. But feet per minute is the result of dividing negative 300 feet by 10 minutes. Okay, so when you divide feet by minutes, you get feet per minute. Now, just to be clear on what actually happened here, we got negative 30 as our result. That means each of these little jumps here we had 10 of them. Each of these is size negative 30, where we are jumping 30 feet at a time as we go down until we get all the way to our depth of negative 300. So we don't know if it happened all at once and then, really slow at the end, or if it happened evenly throughout, negative 30, negative 30, negative 30. But on average, it was about a 30-foot drop per minute. Okay, one more problem for us here. A football team loses 84 yards over 7 plays. Represent this with integer division. How many yards were lost per play on average? So notice again, we have this word per show up. So that is the key telling us that we're going to be dividing. All right. We have 7 plays happening and a total loss of 84 yards. So that means when we fill in these 7 red boxes here, the total that these boxes are going to have to add up to is negative 84 because we lost 84 yards. So we want to find out what goes in each box. What is the average loss per play? Okay, so since we have 7 of these, the way we can calculate this is negative 84 divided by 7. All right, if we need to, we can always work it out on the side. 84 divided by 7 with long division. 7 goes into 8 one time. We subtract the 7. That leaves us with a 1, and we drop down the 4. 7 goes into 4 twice. So we end up with 12 as our quotient, and we have 0 remainder over there. So over here in the middle, negative 84 divided by 7 is going to give us negative 12, because the long division gave us 12, but then we include the negative from that 84. So now using units, because we divided yards by plays, okay, the units on what we just did was 84 yards and 7 plays. The result when we write our answer is yards per play, or yards divided by plays. So we could write it as negative 12 yards over plays, or negative 12 yards per play, where that word per just means to divide. Okay, and we're going to see that a lot, not only in this class, but in real life. So now if we want to fill in those 7 boxes, all we have to do is say that a negative 12 is going to go in each one. And so over the course of 7 plays, we don't know if they lost 12 yards every play, but we know that the average number of yards they lost was 12 per play. So it might have been negative 20, negative 30, negative 1, negative 2, negative 3, all over the place. But on average, it was 12 yards lost per play. So we would say that negative 12 yards per play is what they averaged. That's all I got for you guys in this one. See you in the next one.